Hey, QE decoders. Here's Jan.
Yes, Michael.
Good
Okay.
afternoon.
Okay, that's better.
Yeah, excellent.
Funny thing, funny thing. This time, Discord didn't ask my password. He was
Hmm,
waiting. I said, "What happened?" And then at once, oh, there it was.
interesting. Yeah, I'm not sure what was going on with that.
Yeah,
Huh. Yeah,
it
looks
was.
like my camera angle is a bit off. You can see a whole bunch of
Mhm.
junk in the room. Well, yeah. I
Yeah,
don't know,
in
not
my
much
room,
better.
you don't see junk at all.
Yeah, let's make sure that the doctor's fully in frame. Yeah, there we go.
Mm, yeah. The day I have some time, I have to clean up the mess behind me.
No, it's become a thing. It's like, okay, that's the backdrop.
Yeah, yeah. The day I annoy myself, I don't know what to do. I will clean it up. At least my wife is gonna be very happy.
Yeah.
He said.
But my system works. I know exactly where everything is. It's there.
Yeah, most of the time I know exactly where it is, but not always.
Hmm.
Good, good. I looked into historical modeling.
Hmm. Excellent.
Yeah, not as much as I wanted, but okay. Well, let me share that screen. Um, make it, which one is it? It's this one. Okay.
There we go.
So actually, is it readable this way or a little bit smaller?
It's a little small.
Wait, perhaps I don't need all of this. And then I don't need this neither. That should be better.
Yes, it is. Yeah, excellent.
Good. So, okay. So the SQLite store. So what we had a long time ago was for the very simple cases. I'm gonna move that a little bit to here, so I'm not turning too much. For the simple cases, we had the SQL query tree, which actually just for the simple cases contains one SQL query with the parameters.
Hmm.
So then I'm passing that into an execute query tree,
Hmm.
which in my case, for the simple cases, just becomes my connection string, which I get from my connection factory, an execute query method,
Hmm.
and I get a rollback, which I still have to define. We just the SQL string and the parameters.
I see. Yeah.
Okay, and then, and then it starts again inside SQLite, because SQLite does support parameters. But so we are using last time. Wait, where was it? Yeah. So last time I made this SQLite.cs file,
Uh huh.
which is actually a copy or a limited copy, just a part.
Yeah.
No, it's not a full class. It's part of the class from the project from Frank Krueger.
Hmm.
And Frank Krueger called in his software the software from Eric Sink.
Yeah.
Yeah. So I kept everything from Eric, which was just a low level routines, just translation between C and C sharp, in fact, a translation layer. And then I used just some routines from, let me show that. For example, this is the code from Frank Krueger,
Hmm.
but not the ORM layer, just the calls from SQLite, where you have open, close the database, the prepare statement, step statement, and so on.
Nice. Yeah.
So all these I was calling directly from my connection factory.
Uh-huh.
For example, if we made a connection, we go directly to SQLite and we open the connection.
Mm.
If we execute a query, we prepare the statement, we step through, and we finalize, and we have the result. What we didn't had yet was a query with parameters.
Right.
And so there are two possibilities. One, either I copy in, which I did here for the development, the full code of Frank again, but I want to avoid that because
Yeah.
then you get into, for example, then we go back to, where was it? Yeah. For example, if you drop, you go to the execute. Here, execute a query with parameters. But then he creates a comment. If you create a comment, then you're going to open a connection, which is in itself a lot of code. You create a new comment, which is using a lot of other things here. Yeah, a new SQLite comment, which is a class in itself.
Yeah.
So I want to go the same way as before, just use the routines directly, which is not too difficult, because if we go back to SQLite, so we have these open routines, but we also have bind routines. You see?
Okay, so bind.
Parameter.
Oh, okay, I see.
Yeah, bind integer, double, text, blob, and so on.
Okay, so that takes a C# type and it binds it to a Postgres parameter through the C layer. Okay.
Yeah, and that statement, that is actually what I get back already in my connection factory.
Okay, yeah.
You see, I use the prepare statement, and I get that statement back, which I insert in the steps here.
Perfect. Yeah, so you don't need to go through all those extra layers just to get back to the statement.
Yeah.
You've already got it. Yeah.
So now the only thing, I go back to the full code. Where was it here? I had that bind thing. Where was it? Did I put it? Yeah, here. So here he has a routine bind parameters. And so he checks the type, and dependent on the type, he's going to use the bind integer. So actually, it's not much more than that what I need to insert.
Yeah, and even then, not the entire set of parameter types, because we'll have integers and strings.
Yeah,
I think that's it.
So that's actually the basic thing. And then the parameters in SQLite, they are just numbered. So actually, either they just have names as numbers, or they can be alphanumerical names. So like the P1 and the F1, I can just use them as parameter names.
Yeah.
So I guess it's not too difficult. I don't see any major problems anymore. So let's say the research has been done, but the 5 minutes to implement it are not yet there.
Yeah.
But so
it's really hard to find that 5 minutes.
It's gonna be more than 5 minutes, but okay. But at least the way it should work is clear. I don't see any problems anymore there. So we will have just an execute query, where I have a SQL and a parameter object afterwards.
Mm-hmm.
Because so here the parameters are, that was what I was working on before, but that was not yet working.
Right. Yeah.
Parameters are not bound yet.
Yeah. Okay. That makes a lot of sense. I like that direction. Frank Krueger's abstraction is intended for applications to use. So it's an ORM that you're supposed to be able to pass in application types. Like this execute query of T. T is supposed to be some data type that's in your domain, but we're building an abstraction, so T is not going to be like the type of a fact. That's in your domain. What it's going to be is something like what it's going to be is actually going to be dynamic. That'll be
just a row
interesting.
from our database.
Yeah, and so when we generate SQL, sometimes we generate the select portion of it as well. So I want to select the hash and the data from these facts, and sometimes it's just just one, sometimes it's 7, and so the data type that comes back out is actually going to be complex. It's going to have a collection of fact references, for example, or fact records, and
a list of fact references.
Yeah, and so that that line there that's doing stat.row of t, or statement.row of t, that's I'm guessing that is using reflection to pick columns by name and put them into properties of t, if I were to guess. And that's not going to work for us. So you'll need to have some other way to bind the results, the columns back into the type.
Yeah, because if I look, for example, to the scalar, which I used before, so here it was actually quite easy. You just add a row, and it returned a type, and I added here, make this work for for type T and not only for strings, because in this case it only works for strings. Don't remember exactly why it was. Probably here the column text.
So it's getting column 0 as text. Yeah,
and then before we were using also a non-query, just to delete the things. But it's okay. We just have to build the the parameterized thing now.
Yeah.
And then we will get. But let's.
And I suspect that what we'll have is, rather than one generic execute query method, we'll take that as a template, and we'll have different methods for each of the different kinds of queries that we could execute. Or if you want to get fancy, then have that thing take some lambdas. So we pass in a lambda that converts a row into an object. And that way we can use it to execute this query that is used for, we wouldn't do feeds in the case of the client side. But the various client-side queries will be for load. You're querying from the ancestors table, and you're getting all of the facts with their data. So that's going to return an array of fact records. But then for executing a specification, then you're going to get an array of fact references. And so you'll want to be able to either parameterize this by passing in, how do I convert a row into a fact record or into a fact reference? Or you'll just have multiple copies of this following the same pattern but doing different things.
Yeah, but in that case it will always be a list of fact references, or a list of Yeah.
Yeah, I think so. Let's take a look at. Um,
If I look to the implementation in JavaScript.
yeah. So Janaga server would be the one that has it.
Yeah.
Let me see if I can find a good.
It was the
Yeah,
it was in the
Postgres store.
Postgres store,
Mm-hmm.
and they're the async read. So what we were doing there was, there you have the execute query tree, and if you go to that one, it does exactly what I'm doing, and he's returning a record of rows.
Yeah, let me pull up that that code so we can show that on the stream. Okay. So, yeah, that'll work. Whatever. Trying to get clever with the stream. Okay, yeah. So we're in. I'm in Postgres
Don't see
store
the
as well.
stream.
Yeah, sorry. Yeah, let me do the share thing. This will be easier. Share the screen.
If you want, I can share it as well. Okay, there it is.
Okay. Yeah. So we're in the Postgres store. Read is one of the methods that you'll be implementing, and so you've got execute query tree, like you were saying, and that returns a result set tree. And this is code that that changed, just about 3 or 4 weeks ago. So
I see, because
yeah.
I still have a smaller version, a more compact version of it.
Yeah.
Yeah.
Yeah. So
I didn't update.
Yeah, so the result set is the set of rows. So let's take a look at a result set row. So that's a dictionary of facts by their fact index, where a fact is the hash, fact ID, and data. So when we generate the SQL in the select statement, for each of the different facts that are added, which could be any number of facts based on how many matches you have in the specification, you'll select the hash, the fact ID, and that JSON data.
Yep.
And so result set row is, for each row you've got each one of those facts, F1, F2, F3, and then each of those things. So so yeah, it goes into, in this case, Postgres for JavaScript gives you back this just array of objects, and the fields in those objects are the name of the columns. So we select hash1, which is f1.hash. So it just gives that alias. So f1.id aliased as id1. So go through all of those and pull those out. So this result set fact, that is okay. Yeah, and then you accumulate those as result set row. So result set row is basically the data type that you'll be returning from your execute query. So it's not going to be quite as simple as pass in result set row as t, because it needs to know exactly which fact indexes it's going to expect, and then put those into a collection of result facts.
I'm looking into go to my site here. No, it's completely different. The old version.
Yeah, yeah. The old version, I had this untyped row object, and it passed that further out. So I was putting together these property names further away from the actual execution, and I decided I wanted that to be a bit more type safe. And so part of the refactoring, I said, okay, right after I execute the query and I've got the rows, then I'll pull apart all of the hash, fact, ID, and data properties from each of those rows and put them into something that's type safe.
Yeah. Okay. But so in C# we can in fact do something very similar.
Yeah, yeah. You would just not use Frank Krueger's method of turning a generic result set row into an object, because I'm certain that his, we didn't look at the code yet, but I'm certain that his just uses reflection, finds all of the properties, and then finds columns with those same names. And so yeah, that one we're not going to use, but we can use that as a template, as an example of the same way that you've been doing the other things, and saying, okay, we can. This is how you get column names, and so the column names to look for are these.
Yeah.
But that is only useful for read. So read is one of the methods of the Postgres store that you'll want to do, but another one would be the well, let's think about that. So Postgres store implements storage, and so these are all of the methods that you could implement. Some of them are only used on the server side. In fact, also some of them are old versions. So this is still backward compatible. I haven't yet deprecated or taken out the old versions of the code. So this query right here, for example, that's the old version. You wouldn't want to implement that into your code. So we talked about read. Feed is server side. You don't need to do that one. Which exists is old. Load. Actually, load is server side. Once you have read, you don't need load for the client side.
But read was the one that we used for human interaction.
Yes. And then I started actually using that for server-side code as well. So right next to this, let me go ahead and pull up Janaga.js.
I'm wondering here, where was it in my code? I implemented the load before. Let's see here. I have save, and that one was working. Get fact ID. That's all private methods. I have load.
Mm-hmm.
That one was working.
Okay.
Load bookmark. No, load bookmark was not implemented.
Mm-hmm.
But so load I have, and save I have.
Okay. So you actually might be able to repurpose some of the things you did for load in order to implement read.
Just looking if there is anything else I had already. And query, no, that's the one we are doing now. And these were just, yeah, these are just all the other routines.
Yeah. Yeah, so it's effectively on the client side, you need to just be able to execute a query to get back the fact references that satisfy that query. And let's see, is that true? Actually, wait a minute. Yeah, so read. Yeah, originally read was just for the human interaction. So if you would go through Postman, you would actually hit the /read endpoint, and it would just call directly down to the Postgres store, bypassing all of the other stuff inside of in the way, and then just just execute that, map that into some JavaScript looking stuff, and then return it. So that's what it started as. But then as I developed the feeds, then I realized the communication between the client and server was just about getting facts to the client. So the client then would have all of the facts that it needs in its own storage, and then it just needs to be able to run a specification on its side after it's already collected all of that information and produce those projections. So that looked a lot like read, but it was slightly different. So that's when I kind of started that refactoring of taking the work that I had done for read and then making it work in a way that it could be used by it used actually on the client side itself.
Okay, so we don't use query and we don't use load anymore on the client.
I believe that is true, at least in terms of the JavaScript. So let me switch back to yeah. So I should still be streaming. All right, so here we're looking at the client store. We've got the client side. We've got the memory store, which also implements. There we are. Memory store also implements storage, so we've got that same set of things. And if we look at the implementation in the memory store is not all that useful here because it looks completely different. But if we take a look at read and we see how it's referenced, then things like the fact manager calls read, observable calls read in order to whenever a new fact is saved, then it does the query inverse, and then it calls read in order to put together the projection that was just added. But yeah, this one here is probably the more interesting one. So fact manager read, if we take a look at where that is called, we'll see that it is called here in Janaga query. So new query is just the overload of Janaga query. The old one is the one that's soon to be deprecated. So when you do j.query, it calls read. Same thing with observer when you call j.watch, it creates an observer, and it reads the initial state for that observer, and then it starts waiting for changes And so then it's going to call read again while it's getting those changes in order to do the projections. So yeah, read is now a pretty much the workhorse of the j.watch and j.query. So
And what
all of
was
the read
the
stuff.
difference between what read is returning and query was returning?
Yeah. So going back here, read is returning a projected results versus query was returning an array of fact paths. Um, so basically, you can see fact path is just an array of fact references. So the old style of doing things, j.query just gave you back the raw facts. It didn't do any projection. But read is able to do projections.
Okay, yeah.
So yeah, projected results. Here we've got the actual JavaScript results. So those are just the any type. So you project into a collection of properties. Then now your result is an object with those properties. And if you're projecting a hash, then that's a string. If you're projecting a child object, then that's either an array, in the case of j.query, or an observable collection, in the case of j.watch. But then the tuple, that is so you can keep track of which one, which result it is we're talking about, and that helps with the observable queries or observable collections. So yeah, that's just all of the names that you've given to the match statements. So match this unknown, and so then for that name, which fact reference. So now that's that tuple. Okay, this set of unknowns maps to that particular result, and this other set of unknowns maps to a different result.
So that means that also the code, because the code in .NET is still using query for the moment.
Yeah.
But so there is a difference. There is a difference between .NET and JavaScript now.
Yep. Yeah, that is true. Yeah, I didn't carry that refactoring through to .NET.
Mm.
So I think that means I need to return to .NET and do that.
Mm. Because if the refactoring can be implemented and works on the memory .NET, that would be great, and I can implement it for SQLite.NET directly in the new way.
Yeah. Yep. Okay. Yeah, I think that is the next thing I need to work on.
Yeah, but you have time, don't worry. I will not catch up.
Yeah. Okay. So let's take a quick look at how close the Postgres store is if you were to grab the read stuff. So here's Postgres store read. So yeah, this is returning the array of projected results. Yeah, that data type doesn't exist yet in .NET, so that would be part of the refactoring that I would do. So this final stage here of mapping the result sets, which are the result set tree, mapping that to the projected results. That's I'll take care of that in the refactoring as well. So you'll work from here down, and I'll work on this part and this part. And I think that'll be a good separation. So yeah, from there, yeah. So result set tree will be your data type to implement, because you're already pretty close to in the existing .NET code to having a result set tree. think the only difference was this refactoring that I did in order to make the result set rows type safe. I think in the version of the code that you started with, this was still a dynamic array of stuff.
Mm-hmm. Okay. Because before I was for the load, I was using a fact graph. It returned fact graphs, and actually a fact graph was an immutable dictionary of fact references plus a list. Okay, and the list was because of the order, yeah. The topological order.
Yes.
Yeah. Okay. Sometimes.
Yeah, I remember that. That's very important.
Yeah. Why did we do things? I forget faster than I can learn. All right. So have to. Where was it? Here. So then next to the load and the query, I will have the read then.
Yeah. So in load here, so yeah, you're putting together some SQL, and then execute query fact from DB. Okay, so this execute query, this is actually using Frank Krueger's abstraction, right?
Oh.
No?
Yeah. What I did. So here in the execute query, I go to my connection factory.
Okay, so this is still yours. Okay, got it.
And yeah, which is actually a modified copy from Frank.
Yeah.
I pass in the type T. Wait, what was that? That was here, and then I defined this fact from DB type, which is just the hash data.
Yeah. Yeah, so it's looking for those specific column names, which in the case of load, since load is flattening the ancestor table, that's those are all the columns that you'll get out. But yeah, for read it will be very different. Yeah, and yeah, don't need load anymore because we're not assembling those things and doing the projection in memory or anything like that.
Yeah. Okay, but that's not a bad thing.
No.
Nope. If it's working better with read, why not?
Yeah, it definitely is better, man. I take a look at the old code and it's like, wow, I expected people to adopt this. This is terrible.
Yeah, but once you get a structure, then you see how it should have been.
Yeah. Yeah, and it's kind of funny that I only saw how it should have been when I started working on a new language.
Mm-hmm.
Yeah, and then it was like, okay, I'm taking all of the ugly that I got used to in JavaScript and I'm rewriting it in C#, and then it's like, no, this is ugly. This is C# has this thing called link. Let's do a link. Oh, okay, link makes my mind think in a completely different way. Now I can apply that thinking back to JavaScript. Oh, this is much better.
Mm-hmm.
Yeah, you need to bounce back and forth.
That's where the word refactoring comes from.
Yeah.
Mm. Good. Did you change anything on the replicator further down, or?
Nope, I haven't made any replicator changes yet, or this week. This week I have been focusing on preparing for microservices talk that I did just yesterday. So that is on YouTube, or soon to be on YouTube, at the Improving YouTube channel, which I think is at Improving Enterprises. I think is the full name of the channel. And yeah, what was funny is that in that I start off the talk by just talking about the business case for microservices, why we'd use them, why you would not use them, and then uh, I made sure that there's a very clear delineation. Okay, everything I've set up till now is just regular old microservices stuff you'll hear from other people, just with my particular opinion. From here down, this is weird, special Michael Perry stuff. And then talking about how you can build a historical model based on your domain, carve it up into who is responsible for each of those different facts. Each one of those regions is is a microservice, and then do the transitive closure in order to find the messages. So yeah, just blasted through that part in about the last 20 minutes of the talk. So I was like, okay, if you just came here for some regular old microservices content, 40 minutes, you're good. If you want to see me go crazy,
The
watch to
last
the
20
end.
minutes.
Yeah.
Yeah. Oh, I will look it up on the improving channel.
Excellent. Yeah, I'll send you the link as well, just to be sure.
I didn't looked up LinkedIn yet because you told me that your new social channel was LinkedIn.
Yeah.
But I rarely log into LinkedIn,
Mm-hmm.
so but I think you are there as one of my friends. No, so
Probably. Yeah. Yeah. I'm pretty sure that we connected a long time ago.
must be 3 years ago the
Yeah.
last time I logged in. But
Yeah.
okay,
Yeah. So yeah, yeah, really the only thing that I did on historical modeling. Oh goodness. Yeah. And then I also received a message from Apress. They would like to do a second edition of the book. So
okay.
yes, that's important.
Hmm.
So so yeah, I got that contract signed, and I will be beginning work on the second edition. Um, so right after I finish up this stuff where I'm going to Mexico. Um, so that will be around the end of June that I finish that up, and so July is when I'll start doing the second edition of the book. And for the early chapters, I'm not seeing too many changes that I need to make. There are some corrections that I need to make in how I describe Git in particular. One of my friends is she knows Git inside and out, and she's like, you got it wrong here. Oh, not in an important way. The you know the you know the point that I was making is still made with this error, but it's an error. You should fix it. So I'll fix that. But yeah, chapter 9, which is about the query inverses. I'm just going to completely rewrite that chapter.
Yeah.
Yes, we know a whole new way of thinking about queries now that's just so much better.
Anyway, it will be worth to have that new book, even if it's for one chapter.
Yeah.
Uh,
Yeah.
if it's the day it is in pre-order, let me know.
Okay. Excellent. Yep. According to the schedule that we're working toward, it should be I should be ready to with the manuscript by January. So so yeah, it's not the first edition took me a full year to write. It's not going to take that long. So so I think January is a reasonable time frame.
Yeah, but it will still be a lot of work.
Mm-hmm.
Okay, but that's great news because the book was getting some things were getting a little bit obsolete.
Yeah. Yeah, and I was thinking that I would have to write the math paper in order to then start talking about this other way of inverting queries. But when they said, "Hey, let's do a second edition," I was like, "Well, of course, let's let's talk about the proper way of doing query inverses in the second edition.
So there was still quite a lot of interest for the book if they ask you for second edition.
Yeah, yeah, yeah. I was quite pleased.
Oh, that's lucky
Mm-hmm.
because it's always a deception if you put so much time and effort in it, and afterwards nobody buys it.
Mm-hmm. Yeah, yeah. I've been watching the sales numbers. They've been kind of just hovering around around 10 units per week. Sometimes a little, actually usually a little bit lower, somewhere between 5 and 10. So that didn't feel to me like, like hey, a huge success, and the publisher really wants to have more of this. But yeah, it's print on demand, so there's no inventory. They're not, sitting on a stack of books that they need to ship.
Mm-hmm.
So maybe 5 to 10 units a week is just fine for their business.
Mm-hmm.
Like, okay.
And of course, Harry Potter will sell a lot more.
Yeah.
but this is far more interesting.
Yeah, I think so too. Yes.
I think people don't buy it because they don't know about it.
Mm-hmm. Yeah,
Mm-hmm.
and I can't just make something up in order to satisfy a story point. I need to actually prove my theorems. So yeah, which I think is a lot more interesting.
Mm-hmm. Good, that's good news. It's not 16 hours here, but I would say yeah, let's go to work then.
Mm-hmm.
Unless you still have something special.
Nope. That was that was the big news, and yeah, I just buried that until the end.
No, but glad to hear that. No, then I'm gonna continue a little bit with the parameters.
Sounds good.
Before the telephone starts calling again, and I will be distracted again with other things.
Yeah.
Good, Michael. Thank you very much, and see you next week, Thursday.
Indeed. See you then. Thanks, John.
Okay. Bye bye.
Bye.